Welcome to Module 1, Lesson 26, Percent of a Quantity. After today's lesson, I'd like you to be able to find the percent of a quantity, solve problems involving finding the whole when given a part and the percent. So now we're going to, instead of using the part and the whole to find the percent, we're going to use that whole, that big group, or we're going to find that whole, and we are going to use the part and the percent to do so. All right, example 1. So we have 5 of the 25 girls on the Aiden Middle School soccer team are 7th grade students. Find the percentage of 7th graders on the team. Show 2 different ways of solving for the answer, and one of those methods must include a diagram or picture model. So we've talked a lot about modeling our answers and having a visual for our answers to help us better understand. So we want to make sure that we're continuing to do that to make sure that we have a sound understanding of how percentages work. All right, so first we're going to go through and we're going to highlight our important information. Okay, so there are 5 of the 25 girls are 7th grade students. It doesn't matter that it's Aiden Middle School, it's just that they're 7th graders. It's important that we're going to find the percentage of 7th graders on the team. And it's important that we have to show 2 different ways of solving and that it must include a diagram or picture. Important numbers here. So 5 is important because 5 represents the number of girls that are 7th graders. 25 is important because that tells us how many girls are on the team. 7, though, is not important because that's just telling us the grade level that the students are in. It's important that they are 7th graders because that's what we're looking for. And it's important to know that we're looking for the percentage and that we need 2 different ways and that one needs to be a diagram or a picture. So let's start out with a picture, and I like using that tape diagram double number line hybrids so that way we have a good visualization of what this percent actually means. So if we look at our labels, we know that we have 7th graders is one of the things that we're looking for. And we're using percentages to do so. So we're looking for the percentage of 7th graders. So we're using the numbers that we know to find out what they are as a percentage. So I know that there are 25 girls total. So that would be my whole group. My whole group then as a percent would be 100%. So what I'm going to do now is I'm going to look at how should I split up my numbers, or how should I split up my diagram? Well, since 5 of the girls are 7th graders and 25 is divisible by 5, we can use that to split up our numbers. So we can split this into 5. So 1, 2, 3, 4, and 5. And then I know that 25 divided by 5, so if this is 0, I know this is 5, 10, 15, and 20. But then with my percentages, I have to take my 100% and divide it by 5, which is going to give me 20. So each line represents 20%. So it'd be 20, 40, 60, 80, and then of course 100. So this works out nicely because I can look here and see that those 5 girls, because it's 5 of the 25 are 7th graders. So of those 5 girls, they make up 20% of the team. So now what I'm going to do, so that was my first method. My second method is I'm actually going to use my numbers. So I'm going to use my part to whole ratio, which in this case is 5 to 25. And I know the value of that ratio is 5/25. Now, there aren't 100 girls on the team, but my percentages are always out of 100. So in order to figure out what my percentage would be, I would have to expand this to turn it into 100. So it's kind of like we're making more teams of 25. I know that 25 times 4 gives me 100. So I know that if I multiply my total by 4, that I have to multiply my number of 7th graders by 4, which would give me 20 over 100. And I know 20 per 100 means 20%. So my model and my math gave me the same answer. So moving along to the next problem in example 2, of those 25 girls on the middle school soccer team, 40% also play on a traveling team. How many of the girls play on the middle school team also play on a traveling team? So again, what I'm going to do is I'm going to make that diagram, but instead of making it again, we're going to work smarter, not harder, and we're just going to copy and paste that graph that we already made, because I notice that on here I have 40%. Since I already have 40%, it makes no sense to create a new model. So I'm looking for 40% because here it tells me 40% also play on a travel team. How many of the girls play on the middle school team also play on a travel team? So that 40% tells us I have the percent, I'm looking for the number, and I'm looking for the part out of the whole group of 25. So I look at my 40% and I see that it matches up with 10. So I know that 10 girls play on both the middle school team and the traveling team. Another way that I could look at this is, since I know that 5 out of the 25 was equal to 20%, to get from 20% to 40%, I would multiply by 2. So if I'm multiplying my percent by 2, that should also make my part multiply by 2. It wouldn't double my total, it would only double my part. Because I'm not making it bigger, I'm not making it more students, I'm just figuring out how many of those students. So in this case, it would be 10 out of 25. All right, so we have example 3. We're still talking about that middle school soccer team who won 80% of its games this season. If the team won 12 games, how many games did it play total? So we're going to solve this problem using at least 2 different methods. So like I said, we're always going to start with that visual because the visual really helps us out. So I'm trying to figure out now if it won 80% of its games, and we know that they won 12 games, how many games did they play? So the 80% is important because that's the percentage of games won. So if they had played 100, they would have won 80. 12 is important because 12 tells us how many games they won. So 12 and the 80% go together. And I want to know how many games did they play. So I'm not looking for how many did they lose or win. I'm looking for how many did they play overall. I'm looking for that total. All right, so what we're going to do is we are going to make our diagram. Now this is where the diagram gets a little bit tricky because you're not given the whole this time. But I still need to start by putting out my numbers and my labels. So in this case, I have my percentage. So I'll do percentage on top this time. And then on the bottom, it will be my number of games. So games and percentage. Now I know that 80% matches up with 12, and I know this from the problem. So if 80% matches up with 12, I've got to think about how I can divide up my pieces to get that 80%. In order to get that 80%, I know I would have to divide each box into 20s. So I would have 60, and I would have 40 and 20. Right, so now I'm trying to figure out if 12 is 80%, then how much is 100%? Well, part of the problem is here, if I don't have that last piece, it's really hard for me to figure out what each section is worth. So what I am going to do is I am going to take a step back and I'm going to look at the math of it all. So since I know that 80% is equal to 80 out of 100, okay, so now the model's showing us that my number should be bigger. So that's why we're starting with the model, to show us, yep, my number should be bigger because 80% is not the whole group, it's part of the group. So if I'm looking for the whole group, my number has to be bigger. Since 80% is equal to 80 over 100, I know I can simplify that, and I can simplify that to 8 over 10, which still simplifies to 4 over 5. Well, when I set up my ratios, I know that my ratios are always part to whole. So then when I turn these into fractions and I turn them into the value is set up as part over whole. So in this case, my part is 4 and my whole is 5. Well, if I want to get my part to be 12, because that's how many games they won, how did I do that? How did I go from 4 to 12? And I know that in order to do that, I would multiply by 3. I know what I do to the top, I do to the bottom, and 5 times 3 gives me 15. So I know the total number of games they would have had to play is 15. Now what I can do to double check this is I can look and see, okay, well if this is 3, then to go all the way back to 0, these increments of 3 should work. So 15 minus 3 is 12, 12 minus 3 is 9, 9 minus 3 is 6, 6 minus 3 is 3, 3 minus 3 is 0. It works out nice and evenly, so I know that my 80% does match up with 12, and that it is correct that 100% or all of the games is equal to 15 games. All right, so we have exercise 1, and this is where I invite you to pause the video and try it on your own. You have your own graph there where it talks about the 60 animal exhibits at the local zoo and what % of the zoo's exhibits does each class of animal represent. So I didn't put the graph on here because I didn't have enough space, but I know that the mammals make up 30%, or I'm sorry, make up 30 exhibits, not 30%. And since there are 60 exhibits, so again, 60 animal exhibits, and we're looking for what % does each animal class represent. Important here is that each, so we're looking for all of them. There's 60 animal exhibits, so 60 would be our total or our whole. And in this case, mammals make up 30 of the 60 exhibits. I know that 30 would go on top and 60 would go on bottom because it is the part over the whole. If I simplify this, I can divide both of them by 6 and get 5 over 10. And then if I multiply them both by 2, I get back to that 100. So I know that, oh, not by 2, by 10. There we go. 5 times 10 gives me 50. And I'm thinking, because I know that 30 out of 60 is half, well, that would make sense then that my percentage would be a percentage that represents half. So 50% of the exhibits are mammal exhibits. So what I want you to do next, you have reptiles and amphibians, fish and insects, and then birds. What I want you to do is I want you to try the 3 of those on your own. And you can do one of two things. You can come back and you can check it and then move on to the next one, or you can do all 3 and then come back and check them. Either way, I want you to try it on your own and then come back and check your work. All right, so we have reptiles and amphibians, and that is 15 exhibits. So that would be 15 out of 60. And then I can divide both of those by 15 and get 1/4. And then I can multiply both of those by 25 and find that 25% of the exhibits are reptile and amphibian exhibits. Now, even though 60 isn't 100, we can still use equivalent ratios and equivalent fractions to help us find that percentage. So we find a way to get to 100 to find that percentage. Fish and insects have 12 displays. So 12 of these 60 displays, so my part over my whole. I am going to divide both of these by 12. And I get 1/5. And then I know that I can multiply this by 20. And what I do to the bottom, I do to the top to make that 100. So what I do is I make that whole, I somehow find a way to turn it into 100 so it's easier to turn into a percentage. 1 times 20 is 20. 20 per 100 gives us 20%. Now another way you could have done this is you could have divided both of them by 6 and gotten 2/10 and then multiplied each of those by 10. Either way, you come out with the same answer. And then birds. The birds have 3 exhibits out of 60. And I'm going to go ahead and divide both of those by 3. And I get 1/20. And I know if I multiply both of those by 5, I get 5 out of 100. So 5 per 100, so 5%. Again, what you're trying to do is you're trying to get that denominator down to a factor of 10. So that way you can multiply, or even down to a multiple of 10. So that way you can multiply and get to 100 and easily find your percentage. Right now we're focusing on these nice numbers that allow us to multiply and divide to get to 100. Later on down the road we'll talk about those ratios and fractions that are not so kind. All right, so moving right along, we have a couple more here. So exercise 2. A sweater is regularly $32. It is 25% off the original price this week. A. What would the amount the shopper saved be considered, the part, whole, or the percent? So we're looking at that it's regularly $32. It's 25% off the original price. And so now here, if I look at this, it's regularly $32. So this I know is the original price. And this right here, well, this is obviously the percentage because it has the percent sign. So here we're looking for the amount the shopper saved. Would that be the part, whole, or percent? Well, we said we know that the whole was $32 and that the percent was 25. Okay, because regularly tells us it's the original. So now here I know that the amount saved would have to be the part. So you're not going to save the entire price. That means they're giving it to you for free. The percentage that they take off is going to be just part of that whole price. And so that part is going to be what they saved. Right? How much would a shopper save by buying the sweater this week? Show 2 methods for finding your answer. So let's just skip straight to the math this time. So let's look at, they have 25%. 25% is equal to 25 per 100. And in this case, I know that 25 per 100 simplifies to 1/4. So what I'm going to do is, now this is a rate. So I have 1/4 of the price. So I'm going to take 32 and multiply it by that 1/4. So what this gives me is 32 over 4, which I know is 8. Now, this is not my new price. Up here we said what they saved is considered the part. So this is what they saved. So it's $8 saved. With our model, again, we're going to use that double number line representation. We have the dollars and we have the percentage, and we start both at 0. Our total for our percentage is always the whole of 100%. We know that the regular amount this time is 32. So I want to find a number that both 32 and 100 can be divided by, and I know that that number is 4. So I'm going to split this into 4 pieces. So I have 1, 2, 3, and 4. It's a little bit off, but we can fix that. So now, instead of each of these being worth 20 like they have been, we have to take 100 and divide it by 4, and I know that it's 25. So each box is worth 25%. So 25, 50, 75, and 100. Then I have to take 32 and divide it by 4, and I get 8. So each box is worth 8. So 8, 16, 24, and 32. And then I can look here and see that since it's 25% off, she's going to be saving $8. Now, as I keep mentioning, percentages are tough to work with. They are definitely a challenging thing to completely understand. So I don't expect you to completely understand this right off the bat. You need to take your time and you need to try. The best part here is to try, and even if you are not successful, we're able at least to have a starting point for helping you out with. So what we're going to do from here is I want you to try exercises 3 and 4 on your own. Okay, so that's 4 problems. Each of them is talking about which piece are you looking for, the whole, the part, or the percent. And what I want you to remember is how you put your percentages together in terms of fractions. So when you're looking at the value and the ratio, again, the ratio is set up as part to whole, so your value should be set up as part over whole. This is going to help you figure out where your pieces belong. And then you also want to remember that when you're looking at if this is $24 total, you need to find something that and the 100% can be divided by to help you with your diagrams. I strongly suggest that you guys use that tape diagram with the double number line to help you out. As always, if you have questions, please make sure to write them down, and please make sure that you try each problem.